Hello guys and welcome back to my YouTube channel. So in today's video we shall be looking at RAG, Retrieval-Augmented Generation. So I know that a lot of us have heard about RAG, so we shall see how we'll get this thing done. So before we jump into the code, we're going to look at a little bit of theory about RAG. So what is a RAG? Which is the first thing? So a RAG, Retrieval-Augmented Generation, is an AI architecture that enhances large language models by retrieving relevant external knowledge at inference time and using it to generate a more accurate and grounded response. So this is an AI architecture that enables the LLM to retrieve a particular data from a particular knowledge base, which you must have built for the LLM. And remember, this is done at inference time. Inference time is when you make a query and then it will be able to retrieve this knowledge base to use it to um, answer your query. So what's the essence of this? The essence of this is because there is always a knowledge cutoff for the LLM, all right? Every LLM has a knowledge cutoff where their knowledge ended. And now when you are building an AI system that is specific for maybe a particular company, a particular firm, or for a particular purpose, you know that some data that are relative to that particular purpose or that particular business are not in the LLM. So you need to build a knowledge base that will enable the LLM to rely on in order to respond to queries, in order to generate a response. So that is where the RAG system comes in. All right. So how the RAG system works is that first of all, there will be a search on the knowledge base. It will retrieve relevant documents and then it will now use it to do what? To generate a response in that particular context. All right. So why is RAG important? RAG is important because LLM hallucinates. All right. So when you pick an LLM that doesn't know anything about your company and you are making an inquiry about that particular company, so it wouldn't give you a response about that company because it doesn't have those data. So rather, it will start hallucinating, generating irrelevant responses. All right. So training data of the LLM is static. It has a knowledge cutoff. All right. And then fine tuning is more expensive. So for little establishments, what they do is to build a RAG system. All right. So these are the different limitations of LLM that will require RAG system: the knowledge cutoff, hallucination, and then the domain specific. All right. So now let's look at the core components of a RAG system. All right. So the four components of a RAG system is you need to have a knowledge base. You need to choose your embedding model, build your embedding, your vector database, and then the large language model, which is the LM. So let's look at them one after the other. So the knowledge source is where the knowledge is actually coming from. Okay, so the knowledge can be in a PDF, a database, or an API, a particular API that you need to extract the data from there. All right, so but the easiest form is to prepare data to be in a PDF or a document file. But then any knowledge base you're preparing for a RAG system needs to be thoroughly scrutinized. Okay, you need to prepare it in a neat format so that it will be able to serve the purpose. If you feed a dirty data as your knowledge base, then your response will still hallucinate. All right, so the easiest is to prepare a PDF data or a Word document data. So that is the easiest to prepare. So if it's for a company, prepare a clean data about that particular company in a PDF or Word document data, which we'll now be using for the embedding. All right, so the embedding is now, this particular data will be converted into numeric vectors. Okay, so because these are the vectors that will be able to be searched upon during inference time so that it will be fast. All right, so you use different embedding models. We have the sentence transformers from Hugging Face. We have the OpenAI embedding. So you need to choose the embedding model that serves your purpose. All right, then you need to choose a vector database to store your embeddings. All right, so we have the FIAS, the Chroma, the PyCon. All right, so but in this tutorial, we'll be using the ChromaDB as the vector database, and then your large language model that will now use the data that has been retrieved to do or generate a response. All right, so this is a simple workflow for every RAG system. All right, so it goes from the user input to retrieval from the vector store. It will retrieve relevant documents, pass it to the LLM, and then the LLM will now generate a response. So this is where the name comes from, Retrieval-Augmented Generation. So retrieval means it retrieves relevant document from the vector store. All right, then it augments it to the knowledge the LLM has, and then the LLM will be able to now generate a response. All right, so this is just the simple workflow of a RAG system. So first thing first, we're going to read our PDF file. All right, so we are now going into the coding aspect. All right, so first thing, we'll read the PDF, we will do the embedding, and then we'll store it in a vector database before we now start building with the LLM. So how do we now read the PDF file? Okay, so first of all, you need to install all these libraries. These are different libraries we made use of in this tutorial. We have the LangChain community, we have the PyPDF, we have the LangChain Chroma, we have the ChromaDB, we have sentence transformer, LangChain Hugging Face, LangChain text splitter, and then the more tools. Please do well to install all these libraries. All right. So first of all, we're going to load our PyPDFLoader from LangChain community.document loader. All right. So this PDF loader, will be using it to load the PDF and then read the content in that particular PDF file. All right. So this PyPDFLoader uses the PyPDF in the background to read a PDF file. So first of all, we are going to run this code now. All right, so we'll run this. All right, and then in this particular cell, we are reading the PDF. Okay, so first of all, we'll define the path. All right, so look at this is where my PDF is. I have a folder here, which is the PDF, and inside it, I have the novatech.pdf. This is the data I want to read. All right, so that is why here I first of all specify the folder / then the PDF file. So it's going to go inside here and pick this particular PDF file for me. All right, then I am creating this loader from PyPDFLoader, all right, and then passing the path. Now I now need to read the data from this loader. Okay, so I'm going to read the data from this loader. So by saying iterating between the loader.aLazyLoad, so that I can now read the data from this loader. It reads it page by page. So it reads it page by page. So I'm now printing each page, the data in each page, for us to see how the structure is, so that we'll be able to read this data together. All right, so it's a pedantic model, so we are now using .model dump to print it on the terminal. Okay, so if we run this now, all right, so it is done reading the data. All right, so these are the datas, and then this is each page now returns a dictionary. All right, so now let's look at this dictionary to see the let's look at the keys that it has. First of all, it has an ID. There is no ID here. We have metadata. All right, so that metadata now has a dictionary that is holding both the producer, Microsoft, blah blah blah, and but where our interest will be inside this metadata is the title, the source. Okay, we need to get the source of that particular data. All right, so we need to get the source. This is the total page. This is the page label or the page number. So these are where we should have interest, and then the next place is the page content. So this is the page content. The page content now has the entire data for that particular page. All right, so the page content now has data for that particular page. All right, so that is just what we just did here now. So having understood this now, that we're interested in the page data and then the metadata, so we will be able to now read those data as we go forward. So here now we'll try to read those data. So we're going to create a list pages, which will store all the pages for us, and another one metadata, which will store all the metadatas, all right, for us. So this will store all the metadatas. We'll pick the metadata and then we'll pick the pages. So to read the page data is the page content, which is what we have here. Okay, so it's the page content. That's why if we're iterating here, we are now appending using page.page content and then page.metadata to read all the metadata. So if we run this code now, so we are done. So if we print the pages, we are going to have a list of all the page contents, and if we print the metadata, we'll have a list of all the metadatas. Okay, we'll have a list of all the metadata for each page. So this is for the first page, this is for the second page, this is for the third page, fourth page, fifth page, as the case may be. So the length of this is equal to the length of this. So we have 1, 2, 3, 4, 5, 6, and inside here we also have 6 data, which is 1, 2, 3, 4, 5, 6. All right, so we have 6 data here as well. So the index of 1 here corresponds to the index of 1 here. All right, so this is just how the data are. All right, so we can easily see the page data. Let me print this. So I can say pages of alright, so what do I have here? Is it pages or page? So pages. So I can say pages of 0, which is for the page 1. So I'll be using a print. And then let's run this. Alright, so now these are the data in the page 1. So this is the entire data in the page 1. So you see that here it's quite huge. So, and if I continue to print that of, okay, let's see the page 2. So that this is out of the page 2 and so on. Alright, so this is how the data are. So this is our main interest, and also the metadata. Now let's talk about document embedding. So like I said, embedding is generating a vector, a numeric vector data for that particular um, data. All right, so what it does is it's going to generate a vector data, and then it will also be storing the exact page content, all right, inside the vector database. So when you are now making a similarity search, it will also embed your query and then search for similarities. Any document that matches the similarities, it now retrieves the text data from that particular document and then send back to it. So let's see how we build the embedding. So first of all, we are going to be importing the Hugging Face embedding from LangChain Hugging Face, and then to create our vector store from LangChain Chroma, we'll import the Chroma. Alright, so this uses the ChromaDB in the background. So this also uses the sentence transformer in the background. So first of all, we're going to create the embedding model, okay, from Hugging Face embedding. All right, so this is the model we are using, the BGE based EM version 1.5. So this is the embedding model that we are going to be using, and then we'll set the model quarks, the device we are using CPU. My PC is running a CPU. If you have a GPU, then you need to specify GPU here, which will enable the embedding to be faster. All right, then we're going to create the directory where our embedding needs to be. So I want it to be inside a folder called vector store. All right, so what I have here is to ensure that this is being created in my current directory where I am working. All right, so when you check here now, I don't have this vector store here, but if I run this code now, it's going to create a folder called vector store. That is where it's going to create the vector DB, and then where all our data will be. All right, then this is the vector store. All right, so which is from Chroma, and then I'm setting the collection name to rack data. The embedding function is this embedding model which I've defined here, and then the persistent directory to this directory. Now note, when you run this code for the first time, it's going to take a while because it's going to download this model. All right, so it's going to download this model before it runs, but I already have this model downloaded, so it's mine will run faster now. So I'll run this code now. And first of all, it's going to create this directory and then create the ChromaDB inside it. So let's give it a while it runs. All right, so it's done now. It took 3 seconds, and then our vector store folder was created here. So if I go through it, so the chroma data and everything is here. All right, so let's move further. Then we're going to create a text splitter. So we'll be using this to split our text. Now, what do I mean by this? Each embedding model has a max token that it can handle. All right, so this particular model, BGE based EM version 1.5, can only handle 512 tokens at a time. But now, if we are trying to embed this page, you see that the data in this page is more than 502. So we are going to split our data. So we'll be using the text splitter to do this. All right, so we'll be using the text splitter. So we are importing the recursive character text splitter from LangChain text splitter. So we'll run this, and then we'll create our splitter. Okay, so I want the chunk size to be 450, so each chunk should have only 450 token. All right, so the recursive text splitter, and then passing the chunk size, and then the overlap, and then the separator. So these are separators are, I'll define at what point should the splitting be done. So this should be double new line. So at what point, maybe when it sees any of these separators, should it do the splitting? All right, so I'll create the splitter, and then the splitter has been created. Now this is where the splitting is being done. All right, so remember we have our pages, and then we have our metadata. So I'm now creating the document by saying the document is equals to splitter.create documents, and then the text, I'm passing the pages, and then the metadata, I'm passing the metadata. All right, so if I run this now, you see that we'll have a whole lot of documents that has been created here. So let's look at these documents. Okay, so this is the document. This is a list of all the documents. So each document has metadata and page content. So I'm going to look at the page content of the first one. I'm creating it document of 0.page content. So look at this now. Look at how small this is now. So now let me look at the second one now. So I know we talked about overlap here. So this is where the overlap plays a role. So you see that some part of data here was able to appear here. So this will enable the retriever know that, okay, this continues from here. All right, so that if it needs to retrieve a complete complete data, it knows that, okay, this continues from this particular one, then to be able to get you what you needed. All right, so this is just how the splitter does, or how you'll be able to split the data. So let's move forward. Let's now embed our data. So to embed our data, we are going to import chunk from more ether tool. So what does this chunk do? So this chunk help you to, when you pass a list, then it will be taking it chunk by chunk. So I want to be picking 10 at a time. That is 10 chunks at a time. All right. So, and then we've created the vector store. So I'm saying vector store dot add document, and then the particular batch that was picked from this chunk. All right. So I have two print statements here. This is adding batch. This is done adding batch. And then when the embedding is done, we'll have this done embedding. So let me run this code now. So you see a particular batch is adding. All right. Okay, this is done. Another one is happening. This is done, and then the embedding is done. So it's done embedding our entire document inside the knowledge base. So we are done with embedding. Now let's look at retriever. All right, so now this is how the retriever does. So with our vector store, we are going to say vector store.similarity search, and that will pass a query. All right, so the query you pass is what it's going to use to make the similarity search and then get you a response. Then I'm saying k is equals to 5. So this k is equals to 5 means the maximum number of documents it should return. So I say it should return only 5 documents. So I'm saying how many days of leave do employees get for this particular data. So now let me run this, and then you see that I was able to get documents. All right, so these are different documents that I got. Okay, so I'm going to iterate here and then print each of the documents. So remember, it's document.page content to get the page content. All right, it's here, the page content to get the page content. So I'm going to iterate the document and then print each of the documents that was read. So these are the different documents. So I'm separating each one with a double line. All right, so I'm separating this with a double line. So this was the first one. So when it's talking about the leave that customers should get, this is another one, this is another one. So these are the different documents it was able to return. So with this particular query that was passed to the similarity search. All right. So having understood the embedding and then the retriever. So it's now to now integrate it with our LLM. So we're going to build a RAG chatbot. Okay, so this is the prompt. Now, the best way to do this is to add the retriever as a tool to the LLM. Now, adding it as a tool, the LLM will understand that the retriever is a tool, and then it will be able to use its hand to generate a query that it can actually pass to the retriever that is respective to the question you ask. So this will make the system very smart. Now, at the first instance, you are not just taking your query to the retriever. No, you are just asking the LLM, and then the LLM will then generate a standard query that it can actually ask the retriever and then get the response and then make use of it. So this is the best architecture to actually use for your RAG, adding the retriever as a tool. All right, so it's going to be like a React agent. All right, so now let's look at the prompt now. So this is the prompt. This is the role base telling it, oh, you are a novel assistant, an AI assistant for novel text solution. Answer user query using the Retrieval-Augmented Generation only, using the retrieve data only. All right. Always call the retriever tool before answering. You may call the retriever tool multiple times as needed. So if the response was not generated properly, call the retriever tool multiple times. So this will enable the LLM to keep working until it's sure that it has gotten the actual response. All right. So use only retrieve content as your source. Do not rely on general knowledge. If the answer is not found in the retriever, say the available document does not answer the question. Do you understand now? So these are guardrails. All right. So though this prompt is short, but it's quite extensive. All right, then let's now look at our RAG agent. So this is just basic loading the EMV and then our LLM. Okay, we'll run it. So here we'll be adding the retriever as a tool. All right, so we import our couple of libraries where we'll build our chatbot. We import the tools to use as a decorator for the retriever function. Then we'll import the start graph, start end and message state from LangGraph.graph from okay, this is not necessary, but I have it here. So we also have from LangChain called on messages, human message and system message. Now let's look at our retriever. All right, so this is the doc string for the retriever. Okay, it's taking a query which is a string and then it's also returning a string. Okay, so telling you that this is a tool called to retrieve relevant content from the vector documents or the vector store. Okay, so the query is a string and then it should also return a string. All right, so this is reading the document, which is document does vector store does similarity search. We are passing the query and then return maximum of 5 documents. All right, and then this is where we are iterating the document and then picking each document. We are passing document.page content, which is actual page content, and then we are creating we are using this to create a string of all the documents and then join them together. So we now have a single string. Each document that was retrieved is being separated by a 2-line. All right, and then we return the document. So this is the retrieval. We run this and then passing the retriever as a tool, create a list of the tools, then binding it to the LLM. All right, and then this is the assistant. This is the system message, the system prompt, passing it to a system message, and then the assistant taking an instance of message state and then returning the instance of message state. All right, so the response is the LLM with tool, which we've binded the tool to .invoke. We're passing the system message and then all the list of messages in our messages inside the message state, and then we are returning the response. Just that basic. So we've been doing this before, passing it with the tool. All right, so we'll run this and then okay, I didn't run this. Okay, and then we'll run this again. Okay, that's good now. So we are going to build the graph. All right, so we import the tool condition and tool node from LangChain.prebuild, and then from ipython.display we import the display and then the image. So we add our nodes, which is the tool, and then the assistant. So the graph from start to assistant, from assistant to the tool condition. So if the tool condition return true, then pass it back to the assistant. But if it returns end, then it should end. We compile, and then we are displaying the graph. So let's build the graph here. All right, so this is the graph, just that basic. All right, then let's now test our RAG agent and then know the response that we are getting. So the first query we are saying, who are you? All right, so let's say the response. All right, so let's study how the structure of the response went. So who are you? All right, so it made a tool call, and then the tool retrieved some documents, and then it now gave us a response. I am Nova assistant, the retriever AI powered blah blah blah. So it was able to say this is who I am. But if you recognize something here, it made a tool call, all right, which is the retriever. It passed it, and then look at the query the LLM generated for the retriever, and then it was able to retrieve this data. Okay, so these are sample questions that we can ask, that you can use to test this particular RAG system. All right, so let's use this one. What tool does the AI team use? Like the AI team of this particular company. So we run the data, and then let's go and look at, this is the AI message. So it said that the AI team relies on a set of well-established tools, blah blah blah, and it was able to list them here. So now let's look at the structure it's also to generate this response. So first of all, it's called the retriever, and you see it generated a query like what it passed to the retriever. This was the tool message, and then the AI was able to now use it to generate this response. All right, so this is just, let's make one more query here. And I'm going to, let me pick another question from here. Okay, so let me pick this. How many days of leave do employees get? So I'll say, how many days of leave do employees get? So we also run this. All right, so and then this is the AI response. So let's look at what the procedure it took to get this. So first of all, the AI message, it's generated a query, the tool returns a tool message, and then this is the response. So we'll have 20 working days per year, and up to sick leave up to 10 days per year. So with this now, you've understood how you can actually build a RAG system. All right, so what more can you do? You can add memory to this, so that you'll be at each query the LLM will remember the previous conversations and how it was able to respond to them, which can actually be used by a particular firm. Then you can work towards deploying this on render, or you can deploy on render or any of your favorite cloud services, and this is just how a standard RAG system works. So if you enjoyed this video, give us a thumbs up, subscribe to this YouTube channel. I have a lot of videos that will help you to build on AI and AI agents. Thank you for watching this video. Meanwhile, keep coding.